If you went to a pub quiz at the turn of the century, around 2000, one staple that you'd always see was a music identification round. The quizmaster plays a song, and you're supposed to identify it. A big reason for this disappearance is that, as far as artificial intelligence is concerned, this task is mostly a solved problem. Apps like Shazam and YouTube Content ID can do this with extremely high accuracy, even when in a noisy bar. And thus it's become really easy to cheat in a pub quiz. And that's why, even though this video is about answering questions about music, I'm not going to play any popular music in this video. Bleeding Gums Murphy was never popular. So how do trivia competitions ask questions about music now? In the same way that YouTube videos speed up or distort music to get around Content ID, pub quizzes have increasingly adopted using transformations of songs to ask questions. Identify the song given only a single instrument from the track, cowbell from Don't Fear the Reaper, or identify the song from the bluegrass cover. If you know the answer, put your guess down in the description. In the same way that these questions reward deeper knowledge, there's also been a movement to reward real music knowledge in other trivia competitions. This symphony's second movement features a rising horn call of a C major arpeggio followed by an A flat 16th pickup to a G. And in a real-life setting, this would just be asked using text. You need to know what an arpeggio is, and that it's a chord played in a sequence. You need to know what a French horn sounds like, and you need to know what a C versus an A flat sounds like. Mapping this to an underlying musical score is hard. But of course, as is de rigueur in the Manchester paradigm, afterward the pyramidal sequence of clues ends with a much easier clue. For 10 points, identify this symphony, sometimes called the Song of the Night, which numerically precedes its composer's Symphony of 1000. Figure out Symphony of 1000 was written by Mahler, and then figure out the symphony before Symphony of 1000. Remember that the Manchester paradigm that we talked about before structures questions to go from difficult clues to easy clues, which rewards knowledge and better discriminates between teams. And remember why the Manchester paradigm that we talked about before structures questions this way, going from difficult clues to easy ones. This rewards knowledge and, more importantly, better discriminates what team knows more about a particular topic. But I want to emphasize the virtuous cycle here. Pub quiz hosts were writing lazy questions that essentially amounted to playing an iTunes playlist in a crowded bar. Deep convolutional neural networks allowed lazy pub participants to cheat on those questions. Out of outrage and to restore equity, pub quiz hosts started writing better questions. The next step, which hasn't happened yet, is for AI systems to start using that training data to build systems that have to think a little bit harder to identify songs. So that's what has happened for audio questions. Let's now turn to questions about images in the Manchester paradigm. Similarly, pyramidal questions about visual art describe less well-known details of a painting. A rabbit runs to take cover from the central object in this work, which approaches the viewer. Let's take a look at another painting. A sword stuck in its holder and the head of a corpse are seen near bushes on the lower left. And again, in a real competition, you wouldn't see this beautiful artwork either. You'd need to recall this just from the textual description. If you know the painting well, then you'd be able to answer the question. But if not, since it's a pyramidal question, in the rest of the question, you'll get to hear the rest of the clues, akin to seeing the rest of the picture. For 10 points, name this painting depicting the sea cliffs of Crete and the pair of legs belonging to a drowning youth by Peter Bruegel the Elder. And you can't just run your favorite computer vision system to figure out the title here. Ships in the Harbor? Plowman on the Hill? No, the title of this picture is Landscape with the Fall of Icarus. And there's nothing in the picture that actually looks like Icarus here. Ah, there he is, or his legs anyway. Or going back to our alleged rabbit, for 10 points, name this 1844 landscape depicting a train crossing a bridge, a depiction of the Great Western Railway by J.M.W. Turner. If you know the answer to this question, put it as a comment down below. The most well-known aspect of Bronzino's Venus-Cupid Folly in Time isn't obvious, but it's better known than the rest of the painting because of Terry Gilliam's use of it in Monty Python. So this is how textual clues are rendered. And in the Manchester paradigm, you present the clues in pyramidal order, going from difficult to easy. But these are textual clues. And yeah, perhaps you have to look at a painting or listen to a piece of music to answer it. And I think it would be fun to use visual or auditory information to better answer these questions. Project idea. But the question is still text. Could you ask pyramidal questions when the question itself is multimedia? The answer, I think, is yes. But before I go into that, I first need to explain why for the skeptics in the back. The Manchester paradigm for question answering tries to make questions that are difficult to answer so that it rewards knowledge, understanding, and robustness. Just like Shazam isn't impressive if it only works with clear, undistorted input, that it works in such an adversarial environment like a crowded bar is pretty awesome. If we want robust question answering and true artificial intelligence, computers need to be able to make do with less and employ the same reasoning and recall ability that humans are able to do. Not just any humans, the best humans who are really good at answering questions. So let's see how the Manchester paradigm does that. One way is to have the normal presentation of material, but to severely limit the quantity. For example, on the game show Name That Tune, contestants bid down each other to see who can name the tune with the fewest notes.
I can name that tune 4 notes.
Ross, I can name that tune in 3 notes.
Sandy, name that tune.
All right, Sandy, you get a chance to name the tune. Here's your clue once again. Introduced as the title tune of a 30s Broadway musical, this tune later appeared in the film Young Frankenstein and was revived in 1984. Listen carefully. Here are your 3 notes. Sandy?
The farmer.
If you're blue and you don't know where to go to, why don't you go where fashion sits?
Did you get it? Oh, that wasn't very clear. Let's try that again. But this shows another way how these sorts of questions could be pyramidal. Go through performances from the lesser-known, unintelligible warbling of Peter Boyle to the intelligible but niche performance of Taco to the canonical performance of the one and only Fred Astaire. This is similar to how we structured the human versus computer competition at the Efficient QA event. Give systems a shot at hard examples with little evidence, provide more and more evidence until you see where the first system gets it right. Creating pyramidal examples with n views is much easier than creating n examples of varying levels of difficulty. And you need to have a lot of data if you want to effectively discriminate systems. And maybe we could do this with visual questions as well. Ask a question about landscape with the fall of Icarus by only revealing part of the image, going in reverse order of salience, just like the text of the question did. The hills in the background, the sword and the skull, the farmer, and then finally the harbor with the 2 legs. Alternately, you could pixelate the image, decreasing the pixelation until the image could eventually be identified. Again, if you know what this painting is, leave a comment down below. But wait, Jordan, I hear you say, this just corresponds to different layers or different pools in a convolutional net. This won't make it that much harder for a computer to understand an image. And that's true. Until there's a Shazam equivalent that's as good and as popular for images, we're probably going to have to wait for the kind of innovation that we've seen for audio questions. But some of this is happening. For example, I've seen things like identify the movie or TV show from the Muppetized version. So you can't just identify raw pixel patterns. Someone answering the question needs to understand what part of the image is a Muppet and what part of the underlying image is corresponding to a media property. And if we want a computer to be able to do that, we need to repeat this cycle, probably multiple times. But not just for images, but for all the kinds of questions we want a computer to answer. But one part of this process is helping humans cheat. Am I condoning cheating? No, of course not. Because what this is really doing is helping the smart, clever people who create these Manchester paradigm questions to be more creative. But we as AI researchers can make it easier for that adversarial authoring process to happen. Easier both for the authors, who end up with better output and less effort, and easier for the AI systems that need to train on data to get the most challenging data that requires actually understanding the underlying information. And this is what makes this sort of research so fun. Just as a pub quiz should reward knowledge and add excitement to a competition, we can use that same creative energy to make our algorithms less brittle, more robust, better able to name a tune, better able to understand the meaning of an image beyond the pixels. This is just a single lecture from a course. YouTube likes to show you these videos out of order, but if you go to the course webpage linked below, you can see the lectures in the right order, and you can get resources like homeworks or suggested reading. You can also visit quanta.org if you want to learn about our systems for creating computers that can answer questions, where Quanta stands for question answering is not a trivial activity. If you want to help the channel, provide a big gradient to the algorithm by liking and subscribing.